Welcome, everybody, to the Zion Experience. I'm Jim Shaw. I forget Jordan. Jordan Frank, the other co-host, is on.
I'm here.
You know, we really don't prepare for this.
You know, we're better off to come. That's about all you're going to get. That's what I got.
I have ham and cheese loaf in the refrigerator for days like today.
With that, let's get back into it.
Let's get in our groove. Well, hello and welcome to another edition of the Zion Experience, or as we call it, TZE. We're coming back to you. We're live with one of our good friends, Praz V. I've told him I'm not going to try to pronounce his last name, but he's going to shortly. I'll give you a little bow on Praz, who's the Chief Technology Officer of Agility. But I'm 2 for 2 this week. My co-host Jordan Frank's on today. We've recorded a couple episodes this week, and so it's good to have Jordan back in the seat. And I'm your host, the other co-host, Jimmy Shaw, and we had a little fun getting this booted up and going. You all won't hear that, but we had a little bloopers edition. But we always have fun with this show, and we're glad to have you for a few minutes with us. We're talking today. The topic's going to be talking about robotic trends that you should be looking out for in 2025 and ultimately beyond. We're going to be talking humanoids and how they're going to shape the future of intralogistics and warehouses, and specifically our partner Agility and their robot Digit, and how we're looking and what we're doing with proof of concepts and real work, I'm going to say it twice, in the warehouse that's being done. There's one humanoid company that's shouldn't say that now. There's a couple other that are out in manufacturing space, but Agility and Digit was the first in the warehouse doing real work, and we're excited to talk about it today. So let me introduce our special guest, Praz. Thanks for being on here, brother. We're glad to have you. We met each other about a year or so ago, a year and a half ago, and have formed a friendship. Let me introduce Praz real quick. He's got a good bio here, and then I'm going to let him fill in the blanks that I missed. So Praz is, like I said earlier, the Chief Technology Officer at Agility Robotics. He brings several decades of experience in robotics planning and control, and creating and deploying robots into home, industrial, and outdoor environments. Previously to Agility, he was a VP of engineering and the chief architect of mobile robotics at Berkshire Grey. We know several people at Berkshire Grey that have gone out in the industry, a lot of good people. We've knew them for 3 or 4 years. While he was there, he was deploying fleets of hundreds of robots to logistics applications. So at Agility, Praz is focused mainly on pragmatic, if I can talk, product relevant innovations driven by the vision and strategy for Agility's bipedal robot Digit, as we introduced earlier. And then just that he's operationalizing the company's research and development efforts and continually exploring what's new. Praz has way too many degrees from Carnegie Mellon University. He's got a BS, he's got an MS, he's got a PhD. I don't know if you could have more than that, Praz, but what did I miss, brother? What did I leave out in your bio?
It's a pretty good summary. I did mess around at CMU with a lot of different robot platforms there. That's probably the one thing. I had about 10 years there at CMU. So a shout out to all of my Carnegie Mellon folks who are out there doing great cutting edge robotic research to this day. A lot of folks there really spun out into industry and created all sorts of new pieces of what we call modern robotics. So proud to be an alum there. But yeah, no, great summary. I've just been kind of all over the place in the robotics space and industrial automation, and really now this big trend into humanoid robotics, which I think is pretty exciting.
Yeah, for sure. And, it's always interesting. Jordan and I had this conversation. I think I shared it with you as well. Is if you look back at the genesis of what now has become the humanoids robotics market, it's kind of like 6 Degrees of Kevin Bacon. If you all remember that from a long time ago, like you can almost go back, like there's a genesis point of this group of really smart people that have now spread out to multiple different companies and in different, robotic applications. but it really was, there was a small nucleus of people that it really grew out of. Pixar's got a similar story of all the digital animation today. There really was a group going back to Utah in Provo, that there was a group that started, and like, think of DreamWorks and Pixar and everything today. And so robotic humanoids are similar. And I don't have the grandfather of it. I read, I listened. It was one that went back to Boston Dynamics, I think. But there's a group of people that came out of multiple little centers that have become the humanoids markets, at least in the Americas. I'm sure it's different internationally, but
Yeah,
when you say CMU and Carnegie Mellon, like, everybody's kind of interconnected, and it's this big, gigantic world. But you can probably name back 2 or 3 degrees back to where it all started.
Yeah, that's definitely the case. You have folks like Jonathan Hurst, who trace back to, Al Rizzi back at Carnegie Mellon, tracing back to, MIT and the Leg Lab there, and, Mark Raybert and Al Rizzi at Boston, going to Boston Dynamics, and Jonathan going off and founding Agility, and, the folks that worked on the DARPA Robotics Challenge, right, which was really pushing what at the time was a pretty, I would say, not nascent, because humanoids had been around for a while, but it really forced them, in the same way that the Grand Challenge and the Urban Challenge really forced self-driving to kind of get to that next level where it was ready to go towards commercialization, right? In the same way, the Robotics Challenge really pushed to say, hey, we realize that there's some technology out there that works in the lab, but let's take it out of the lab and try and make it do some stuff. And we've advanced a lot since then, but I feel like a lot of the folks that did that advancing kind of came through that experience, or were somehow related to the labs and the people that were involved in that project. And so you really do have this evolution all the way from this small group of people just exploring dynamic robots and saying, like, no, I want a robot that is doing really dynamic actions, not just moving around kinematically point to point, but really like storing and releasing energy. And then that kind of evolved into this diaspora of folks who then came back together for things like the Robotics Challenge, with this notion of, how do I control an articulated robot that might have to do balancing and things like that. And those folks, kind of formed the seed pieces of technology that I think have led to what makes humanoid robotics capable today. All of the things that you see out there on the market right now, and out there in the research right now, moving around, picking up stuff, being really robust to all sorts of, different environments and things like that.
Yeah, I got a question for you, bro. It just reminded me of something. We were at the Humanoid convention this year, and it felt like there was a lot of research academics that were pitching some of their things that they're doing with humanoids and AI and whatever else. And knowing that Agility has really started in that research, but really gone some more of that commercial side of things, how difficult of a task is that, moving it from the lab to the commercial side of things? It seems like it's a pretty big challenge that's hard to figure out. But I'm curious, because you have that experience from your point of view. What was that like?
Yeah, I mean, I'd say it's at least half of the overall work is in the productization. And if you're coming straight from academia, it's easy. I certainly, when I first went from academia into industry, it was a shock to me how much work there was left to be done. Just because all of the pieces necessary to take something and actually keep it working out on the field, you don't really even think about. In research, you get it to work for 2 or 3 minutes, you get the results you need, you put them into a paper, and you say, like, check the box, like, we showed that it could be possible, right? But then you're like, okay, but like, if I want to run this tomorrow, the day after, if I want to give this to someone else to run who's not me, there's a whole other level to what the technology needs to be able to do, and how rugged and standardized it needs to be, so that any particular unit can go to any particular person and you expect it to work, right? That's a huge, huge bar, right?
Yeah, and keep it, realistic from a price point, because it's like, yeah, sure, we could throw everything we can at this, but then if you put yourself out of a price point that is under competitive, well, you're not gonna be in a good position there either. So you're battling both, to your point, making it work across a variety of different environments and with different users, right? Like if I design something and I know how to use it, I can probably make it run pretty good. But can you? And if you can't, then it's not a very good product. But then also keeping your costs down. So
yeah, I mean, really, that goes towards this fundamental piece of having product market fit, right? It's no good if you have a really capable robot that can't solve anybody's problem, where that includes the price point, the ROI, and the actual capability they're looking for. If you have an amazing robot and it can do all sorts of crazy things and teleport around and stuff, but it doesn't actually do anybody's actual work that they need done, like that's not going to be a successful product for anyone. And so that's where you have to really spend your time, is making sure that, okay, I can get this to solve something, but is it something that somebody needs, and is it going to do it in the right range and the right price point for what they need, right?
Yeah.
While we were sitting here talking, it came back to me too, Praz, is I think the first time we actually met, you had much longer hair. You've since cut it. And it was about this time. It was a year ago, whenever Manifest is. I don't know if Manifest is next week, but I remember you were up speaking. We were in the process of talking about having a partnership with Agility, and you and there was a lady from Locust, and her name is escaping me. I think it's Gina. Yeah. And then someone else were on a panel, and it was I just remember being really impressed. Like, man, that guy speaks really well, and came up and introduced myself out of the blue to you. And here we are a year later. So we're totally, we say we don't have a script. We were supposed to ease into another thing, but this is what we do for us. So
I was curious. I couldn't help. I had to just
well, I started it.
Yeah.
It's all good.
Yeah.
And then,
No,
I think it's all relevant. Like, where does it start? How do you create something? Everybody thinks this is easy. I think the marketing side of the humanoid and even robotics in general is just, they make it appear like it's easier than it is. And like, this is really, really hard work. This is years of research and development. It's not easy. And it at some point will hit an exponential curve where it appears easy and you hit it at scale. I don't know how far off we are from there, but to get to the point where you got something that somebody wants, I think you said that, Prize, something that's cheap enough for somebody to afford, something that's safe enough for somebody to work with, and functionally does whatever it was designed for, like that life cycle, that's tough. Mm-hmm. And it's years of evolution of going back into how it works, but it's always fascinating. So let's just flip into, while we're here, we want to talk about Digit. You may bring in Agility Arc a little bit, the software side of what software controls Digit, but mainly Digit. Just in your view, tell us about Digit. If we were a brand new person we've heard humanoids, we know what it is, just give your 3-minute elevator speech about Digit. And I'm going to try to bring up a video or picture while you're doing this too. So,
all right. So Digit by Agility Robotics is our humanoid platform. So 2 arms, 2 legs. It walks around for doing right now material handling in warehouse, logistics, manufacturing applications, a wide variety of applications. So it's really flexible. It doesn't require a lot of infrastructure. It doesn't require any modification to your layouts, or at least minimal modification to the layouts of existing flows. But really, we built Digit to be this multi-purpose mobile manipulation platform. It can go into the spaces that you've already designed around your human-centered flows, brownfield environments, facilities you already have, and it can automate those flows that are kind of maybe between other pieces of automation, or where you might cycle it between a couple different stations that each wouldn't be able to sustain a dedicated piece of automation. And the real benefit of being in the humanoid form factor are that you're minimizing how much you have to fit to the automation, right? Digit can come in, you uncrate it, you bring it up and map the area, and then that's what you've done. That's it. That's the deployment process. And we've just been continuously working on increasing its capabilities and decreasing the amount of infrastructure required to deploy it. Things like the guarding that you need right now from a safety perspective. We're really working on making this platform that is just the glue that you can put anywhere in your facilities to connect up these different operations. And to your point, Jim, it's not easy. It takes some time to build up all of that, and we're starting with a particular set of tote-based flows and expanding from there. But what really gets me excited what I think gets a lot of people excited is that everything that we're building, everything that we do to make the robot more robust, easier to deploy, more general purpose, that just builds on the same platform. It's not 12 different robots for 12 different use cases. It's not, hey, I'm going to go in and this particular thing is going to need a construction permit for these conveyors and things like that. We're really trying to minimize all of that and say, hey, we're creating a platform where every time we roll out a software update, every one of these units gets more capable, and everything just sort of keeps leveling up as we go. And that's got me really excited, coming from other spaces in industrial automation where it's just a long cycle to customize everything to fit in a particular place to work really well in that one spot. Then you go to the next spot and it's like a reset. You're starting all over again. And we really want to create a platform where we have this flexibility and capability out of the box every time.
Yeah, I mean, we got to spend some time at your facility, and obviously we've had a couple of interactions with Digit through the trade shows. I know you guys are going to be at ProMat, and Digit will be on display there, and it's the more you get to know about it, the more, this is just surface level, you realize how difficult it is and what you guys do and how impressive it is. And it comes down just to simple things like walking. Like, I would have had no idea, none, that getting a humanoid to walk was as difficult of a challenge as it was. I know that it's become a little bit faster and faster as technology does, as these new companies are entering the scene. But I think the fact that there's been multiple cases where Digit was out walking, untethered, unguided, in kind of a public environment. You've got some demos that are out there. And when we first got engaged with you, the strategy was more of a crawl, walk, run type of approach, so that you can continuously learn from the data out in the field, the use cases you have, to your point, to continue to evolve and build upon Digit as it is. Yeah, there's new updates, there's new versions, new functionality, but the whole part of it was, instead of us trying to go out and solve every single problem at once, you guys really focused on a singular problem, which was tote handling. And there's a variety of reasons for that, but you continue to get better and better and better, it seems like, at manipulating those totes, different use cases. I know you had some different end effectors on a recent version that you had, which was pretty neat. So it's been pretty cool to see Digit and just the evolution with just the past year.
Yeah, these are our V4 alphas that you can see in this video here. And we've been evolving, the hardware that we're using to try and better fit these use cases. And we have really had a focus on trying to finish solving one problem before we keep hopping to different verticals. It's important to us that we can get the robot out there in the world, working at customer sites, which is what we've been doing at places like GXO. A robot is there every day working a shift, right? And the learnings you get from that about what you need out of the platform are just invaluable. It's stuff that you'd never be able to figure out in the lab, to just understand, how are people using this? What are the types of issues that you really see out in the field? Not like hypotheticals about what could happen, what does happen. And then you incorporate that back into upgrading the hardware for the next generation, upgrading the software to improve your reliability and be robust to different types of errors, and really add the capabilities that unlock the things that your customers actually need. So we've been very focused on that for that reason. If you go too broad all at once, you just never really go deep enough in any one area to understand what customers need in those areas. You're never forcing yourself to get all the way to the finish line, right? But it's pretty exciting to get to see Digit in all these different use cases and working with all these different systems with really the same core technology of just really solid material handling.
So you all have got some heavy industry vets over. So we met Jonathan, you got Melanie over there. Melanie was part of Fetch before it became acquired by Zebra. You've got background obviously in academia and, real world application at Berkshire Gray. And we know Pete, and I'm sure there's others we haven't met, but just how does that whole group work together? Like, how do you all divide and conquer? And it sounds like you spend most of your time on, it's more R&D and what's it going into the future. Is that accurate? Or how do you and Melanie and Jonathan, and how does everybody kind of divide up what you do on a day-to-day basis, Praz?
Yeah, so you can think of it as this continuous pipeline, and some days we all just sit down and argue around a table. But how it kind of works is Jonathan and I,
Who
Jonathan
wins
and
the
I are
argument
looking.
most day?
I'd say there's a fair amount of time Melanie wins the argument.
There you go.
But Jonathan and I are off looking at what's next and what do we need to incorporate. We're looking at things like the newest AI technologies, new types of hardware that we're incorporating into the robot, and what types of fundamental properties of the robot are going to unlock our capabilities. And we have an innovation team that explores those different areas and figures out some of those pieces. And we produce in that team some stuff that goes into things that are, YouTube demos. We're showing off capabilities that we know the robot can do. They're not productionizable. And that's things like maybe picking up candy is one that we've done. We've done laundry sorting where we sort different clothes into a hamper. That's us pushing the limits of what's possible and figuring out how to do it. As we pick up those pieces of technology, I work with Melanie and other folks on the engineering team to turn that into what's going to flow into our next generations of product. So we incorporate some of those pieces into the software that the engineering team develops and the product roadmap that her product team produces. We sort of fold in, okay, here's how we can see how these capabilities might fold in. And then there's a large unit of work of taking those pieces and also just the general engineering that needs to be done to harden the platform and improve it over time. And the engineering team is really focused on that product side engineering, where it's like making the next generation of robot that's going to go out in the world in quantity and be able to do all of these things. So it's kind of this spectrum that we're working across. And I sort of sit in the middle of that, and Jonathan sits on one side and Melanie sits on one side, and we all work together. And at the end of the day, what we really want is to be able to touch all of the latest technology and make sure that we really understand it and understand the physics and the theory of how the robot moves and interacts, and also be able to pipeline that into the product focus of making sure that we can turn that into something that's useful to customer and is going to do what our customers need and do it reliably and safely at scale, right? And so there's a whole spectrum, and we kind of span across that.
Gotcha. It's cool, which is a good transition to like 2025. I know we're focused with Pete on finding a proof of concept. So how do you put it out in a customer site? How do you apply it? What you've got 5 use cases really, or workflows as you all call them, that are 5 is kind of the high level side of it, right? Of what you're getting Digit capable of doing in the real world. But look out, like you're probably more in a visionary seat. Like where do you see Digit going in 2030? Where do you see Digit maybe 20 years from now? Just the industry. And I know everybody's got there's a lot of hype around it. It seemed like 2024 was the year of the humanoid, and a lot of hype and some detractors against it. It's like it's overhyped, but I've got an opinion of where it's going to be in 5 then 20 years from now. What's your opinion?
Yeah. So, I mean, ideally 20 years is enough time to unlock quite a bit of capability. So my hope is we could see this technology really rolled out in a variety of industries. I think that's the thing is industry and commercial. I think there's pretty good paths for us to go towards. Home is kind of the interesting one. In home, robotics always has the challenge of like, what will people accept in their home, which is entirely orthogonal to what robots can do in a home, and what capabilities are available. There's a lot of times when some home robots they do their job perfectly fine. It's just nobody wants them to do it in that way. That's not. But there's industrial and commercial applications where the bar is clearer, right? Value prop is clearer. It's, if you can do X, Y, Z, I will put your robot in. If you can move totes at this rate, if you can restock shelves at this rate. So I think from a next 5 years perspective, that piece is definitely clear. We want to be going from tote movement, expanding into case movement, and doing things like machine tending and manufacturing, which from our perspective is pretty incremental. We basically unlock a huge amount of it with safety, figuring out the industrial safety to be able to deploy, and then incrementally improving our manipulation capabilities, which is something we're pretty focused on and is rolling out across the next 2 years, increasing that manipulation capability, and a huge unit of work around being able to solve the industrial safety issue. So right
Gotcha.
now, a robot can work inside of a work cell. And that means that anywhere you put it, you kind of have to separate it out from people
Sure.
physically. You have to put a barrier or have it over here behind something that keeps people far enough away in space. So the big unlock that lets you have humanoids that are able to free roam your facilities is being able to take all that safety and run it essentially on board without needing a whole bunch of infrastructure. And that's what we're focusing on for our next generations of hardware.
Yeah, Pete was telling, we met with Pete. We've got what we call partner business reviews. With our strategic partners and even all down our partner list. And we were meeting, and my week's running into last week, but I don't remember if we met last week or we met this week, but it's one of the last 2 weeks we met with Pete and we were talking. I think there's a date in a year that said safety wise that Melanie's made a statement that you all had some press on that. Is it this year? Is it next year that it's going to be safe enough to work around humans in that environment, in the warehouse environment?
Yeah, so that's our plan for our V5 platform, which is the next hardware generation after the one that we're releasing this year. And that is 2026. So next year, we plan to have that out there. Now, internally, we're going to be working on it straight. Like today, we're working on it, right? It's right there. But
well, they're safe today, though. I mean, there's not like it's going to walk up. But the problem is I'm going to use the wrong terminology. You'll use the proper technology. But because of how the battery life is and how it's powered, Pete said the word. It's like basically if it stops and the battery goes dead, or it falls, right? And that's the solve is going to be one of the safety aspects of how you have it around someone. Because tell me the right proper term. What he told us, my memory's terrible.
Yeah. So what you're describing is the stop category. So a category 0 stop is you just kind of cut all power immediately. And that doesn't work so well when you've got a dynamically stable balancing robot. Cutting all power, not so great. So actually our V4 beta units, the ones this year, actually incorporate a category 1 stop, which is that they take a bit of time to try and get themselves down onto the ground in a stable manner before they de-energize. So we're solving for that actually in our next generation of robot this year.
That was a word. Dynamic de-energization, whatever.
Category 1 stop is probably the one to remember.
He didn't use that. So, that's a new one, but it was something around how it energizes. So
So, but that's absolutely right. So that's an important component of being able to safely limit the robot, right?
Right.
Now, our robots.
I do want to say though, Praz, I keep cutting you off, but like I don't want the listeners to get the impression it's not that they're not safe today. That's not at all. It's just
absolutely
when you're thinking safety in an environment, you almost got to think through every possible situation where a human interacting with a machine, which it is, that there's safety standards put in place, and they don't exist today. You all are cutting edge with defining of the safety standards in the U.S. at least. Maybe it's a global organization of what's the safety standards for this new form factor of a humanoid robot, right? So I just want to make sure the audience hears that instead of it's like, it's not like these things are out and they're unsafe, but you got to think through all the ways.
I think this is an area actually where we spend a lot of time and not everybody in the industry spends as much time as we do. So yes, our robots, we deploy them with compliant safety strategies. And we do that by laying out work cells that are designed so that when you have Digit in them, overall, that whole work cell is designed to keep you safe. And so Digit's getting wireless safety signals from, a PLC outside the system that's tied to the rest of the facility safety. You might use things like a waist high barrier or a shoulder high barrier, such that if you're crossing that barrier, we can signal to Digit that you're about to get into the vicinity of Digit and Digit can shut down. Or we can use things like interlock doors, light curtains, stuff like that. So that's how we employ our safety right now and get to compliant safety strategies that we can deploy in facilities that do meet all of the compliance guidelines that are all of the industry safety guidelines that we're expecting. But what we're trying to do is we're already able to do that safely, but that still requires that there are these other pieces of things that you might need in the area to set up your work cell. You might need a guarding panel in some corner. You might need a door somewhere. You might need a light curtain somewhere. And so really what this is about is improving our safety strategy to reduce the amount of other stuff you need to do in conjunction to build out that safety strategy. We're saying, okay, we can put more of that on board the robot. We can put more of that sensing on board the robot so that you don't need to modify as much of your facility to come up with a safe strategy for deployment. And that's the big difference, is we want to lighten that load and decrease that barrier to entry, and also open up the size of the area where Digit can operate. Because obviously, if you have to put in any sort of infrastructure, that doesn't scale well. If you need Digit to go around a lot of different areas of the facility, you can't put work cell stuff across all of that. You end up with regions where you can put it, and then you have to kind of move Digit from cell to cell. And so that's really what we're trying to do there, is reduce that barrier to entry for safety, but not that we aren't safe right now. It's just, how can we do it more easily?
Right. And ultimately get it to a point where it scales. So that's I mean, that's your all's ultimate goal, which makes total sense. So let's turn the corner a little bit and just the advantages. And you've already hit on a little bit of these, but humanoid robots in the supply chain, inside the warehouse. We're a systems integrator. We have great interest. One, we love new technology. We love things that make humans' lives easier. Our core purpose of our company, Pros, I don't know if I've ever shared with you, is to leave a positive impact on the lives of those we touch. So it's often said, where do humanoids play? Where do robotics play? Industrial robotics in general. It's anywhere that it's, I'm going to steal some of the language: dull, dirty, dangerous work, right? And there's a fourth D, and I always forget it, but we are interested in it because, one, it's cool technology. Two, I have been in the back of a warehouse, in the back of a 53-foot truck, unloading boxes all day long. It's just not fun work. It's hot or it's cold. It's not fun work. It's repetitive. Every box size could be 0 to 75 pounds or more. Where do you see this really getting into? Our customers want to know, when we're talking to them, like, where could Digit help us out today, 2025? Where could it help us out? And then you've already talked about going into the case and, obviously different forms of manipulation, but short term, I've got a customer on the line. Where do you tell them to look for Digit?
Yeah, so I'd say right now, the places where we're doing our engagements are primarily around moving totes around between other workflows. Totes are a thing that we handle really well. We've got some manipulators that can handle pretty high load totes at this point. So this is the paddle style gripper. I think if we look at the latest generation of Digit,
video of the other gripper, but yeah,
that's right. We've got another style, which is more of a pincher style gripper, and with that we can get up to 16 kilogram payloads moved around pretty well. But all of these, what they have in common is they're all totes that are moving between these flows. Like, you've got an AMR and you want to unload it to a conveyor, or you want to take a pallet and depalletize it to a conveyor or to an AMR, or you want to unload a shelf from, like an automated put wall system and load an AMR with that, or load a conveyor with that. It's connecting up all of these different processes where you end up with, here's one process upstream, here's one process downstream. This process outputs totes in some format. This one receives them in some other format, and they don't quite meet in the middle, right? You end up with, hey, these two systems are not quite matching, and it's expensive to connect them, right? It's expensive because either it's something that you have to replicate in a lot of different stations, or it's something that's really complicated to automate because of the workspace or the constraints or something like that. That's where we've seen a lot of traction. That's where we see customers getting a lot of value out of the system because it's easy to deploy. You don't have to change your upstream or downstream process very much. And if you fit within these wheelhouse categories that we've already had a lot of experience with, it can be quite fast to deploy.
You're on mute there, Jimmy. I'm sure you're saying something very profound.
It was
about dynamic de-energization. I can't say it either.
Yeah,
right.
Don't be throwing shade. I just made the word up. I can't pronounce anything, but that's okay. So I was saying that there's a really good video you all have got. I'm trying to find it. I'm trying to both host and be background video, and I'm not doing probably a great job if you're watching the video. If hearing, you can't tell, so I just told on myself. But there's a real cool video you have of the 5 workflows, and it's digit working in multiple, what you just explained, Praz. So I'm going to try to find it in a minute, but thanks for that explanation. And then just what do you think's the next big leap? This will kind of be the last question we have. What's the next big leap in your opinion in humanoid robots as it relates to the supply chain?
Yeah, so I think we're right on the cusp of kind of all of these pieces coming together. So we've been deploying humanoid robots out in the field for some time now. And by the field, I mean like in warehouses, in manufacturing facilities. We've found, kind of the last tent poles, I think, for really unlocking this. There's some amount of improving the manipulation, but we're moving stuff pretty well right now. We're able to hit, customer throughputs, and we're seeing those inch upwards. And then really the longevity of the robots and the safety of the robots are both pieces where we're almost there, and we have kind of a few big unlocks left that I think we're going to be able to nail out within the next year or so. And so that's where I think all the pieces kind of come together. Then you've got a robot that can do the work, it can safely be deployed, and it can meet customer expectations for throughput and reliability. And once you kind of have all those pieces together, then you can really start playing with this technology. And I think that actually, a lot of people think, hey, it's going to be a specific manipulation capability, like that's the big unlock or something like that. I actually think it's more along the lines of, if the core platform meets all these pieces, right? It can get there in terms of getting out into the space, doing the work, and it's easy enough to deploy and it's safe enough to deploy. Then I think you have this just incremental progress on being able to expand the workflows. If you look at, what we're showing here, this is a lot more than what we had last year. We have been just adding and adding and adding to the capabilities of the robot over the past year. And this is without even getting into the improvements that we're adding from a hardware perspective in our next generation of robot. This is just software unlocks on the existing platform that we've been showing for the past year and a half or so. So I think that's kind of the exciting part for me, is we have a few tent poles that we're working on, but we have line of sight on them, and they really are what I think will unlock broader deployments of these systems. Once you can kind of check all the boxes down the line and get them into these use cases, I think there'll be pretty rapid expansion of the capabilities once we hit that.
Yeah, I think the future is exciting in this side of the industry and what you're doing. And just, it's always fascinating to me to hear, we're going to leave the video playing of just, I remember 2 years ago when this really debuted you all made your debut at ProMat. So we're 2 years, almost a month away from 2 years from that. And all you had was the tote movement, kind of where you all started. And just that's what was the attraction to you all was, one, we just kind of clicked with it. It's you got to like the people you work with, and everybody we've worked with at Agility has just been good people. And then 2, you all aren't trying to boil the ocean, as the saying would be. You all are very focused on crawl, walk, run, and you've got a lot of really smart people that are solving problems that are going to be real problems. So it's not hype, it's not PowerPoint slides, it's you're out doing the work, and you have, I think, a very measured intentionality of how you're approaching what problems the humanoid and the form factor as it exists today, and where technology, call it generative AI, and it's lacking of what problems you can really solve. So I think that's what attracted us. We know we're not going to go sell 10,000 digit robots in the next 12 to 18 months. We'd hope that, but we think it's going to solve customers' problems, and that's one of our brand promises is to guide intelligent change. And I know Jordan and I speak for both of us. I think when we 100% believe these will be in the warehouses of the future. Don't know exactly where, don't know who's going to win the speed game yet. I know there's a lot of people trying to solve it, but we're pretty grateful we're aligned and partnered with you all and the good people at Agility. And so we probably got a chat from Amelia. I'm supposed to wrap up around 35 to 40 minutes, and she usually tells us. So I think we've gotten all the questions, those out of the way. Is there anything else, Jordan, you want to ask of Praz, or Praz, you want to? I did a bunch of asking yous, or anything you want to ask of us before? I got one fun question we usually try to end with, and is there anything anybody wants to say before I get to it?
Well, I mean, thanks, right? Thanks for having me on here. Thanks for the partnership. It's been really great working together, seeing you around at different events, and learning from you guys. You guys have a wealth of experience in going out there and getting things deployed in your own right. And so, hearing about it and getting a better idea of what we need our product to do is always valuable to us. So, here's hoping we can get to that 10,000 soon enough, right?
That's right. That's right. We're hoping for a proof of concept this year, get to working on. We're working really hard together jointly on that. We got some time planned during ProMat. If anybody's on this, we're gonna have a panel with Pete, Jordan, and myself, and we're gonna just talk about, hadn't found the title yet because the smart people in marketing are working on the title and topic, a catchy title and topic. Everything I suggested, it was too long, so they're trimming it down, Bras. But we're going to talk about how do system integrators and humanoid OEM integrators work together, and why do you need both? And I think both, listen, I'm not smart enough to make it walk and talk and move and grab, but we are smart enough to say, where's it best applied inside a warehouse, and how does that work, and what process does it need to flow, and how does it integrate with the other systems around it, and think through that. And I think that's why that's the value of the partnership. And so, yeah, thank you for that. And then let's, you got anything, Jordan? Or see, Jordan did all the talking, Pros, on the last one. He took over the entire podcast, and now he's
sick. I got kids running around in here. I got a lot going on. So
you got the dogs are chasing Amazon people. Yeah. It's a new sweater. I've never seen you in this sweater or pullover or whatever you got. You've got 1,000 of those evidently, and this is it, Pros. This is how we roll. So one day it's him doing all the talking, and another it's me. But let's ask a fun question. I got some different ones. And I'm going to do this because maybe you're doing it, but what was your dream job growing up, and how did that affect your passions and the job you chose?
So this is an easy one because you're right. This was my dream job. I was always into robotics. I have an old VHS video, or rather my parents have an old VHS video of me building a humanoid robot out of Legos when I was 9. An actuated one. It had a motor and it walked. So this has been my passion pretty much since I knew what passions were. So it's been an easy road for me to figure out what I want to do next, because it's always been getting robots out there and making them do useful stuff.
That's pretty cool. We might have to explain to some of the listeners. Amelia, I'll tell you what a VHS is after we hang this up. You may already know. I'm entering that point in life, Pros, where there's things. It's like, what's a phone book? What's a payphone? What's a VHS? I remember we've got a ton of VHS. My dad we had the giant one, if you remember.
Oh, yeah.
There was a little mini one, and Big Jim.
This was recorded on the big elephant.
Like it sat on your shoulder. You'd have to do it the whole game. And my parents have actually taken all our old VHS and burned them onto CDs, just as my mom did that as kind of a Christmas present for my brother and sister and I, and a lot of family memories that way. But that's pretty cool that you're getting to do something that, that long ago you were interested in, and you're getting to live your dream and your passion now. And you're a good person. You're a good partner. We thank you for the time spending with us, and just, appreciate it. And we're going to do the outro here in a minute, but if you made it this far with us, thank you for listening. And, we're always glad for people that listen to us, and hopefully you gain some insights to where robotic technology and humanoids are heading into the future. And I know I'm sure excited about it. And I think I share that sentiment with a lot of people. So, Pros, thank you.
Yeah, thanks, Pros.
Thank you.